Assalamu alaikum. This is Azim Baksh, Worldwide Physics Examiner. Today I'm gonna explain another physical quantity, and that is displacement. So after knowing the name of the physical quantity, next things we need to know, that is its symbol. So the symbol is D, and there must be arrow tip line above it. Just the difference from my previous video of the distance, we represented distance by d. So if this is d, this is the distance. And if it is d with the arrow tip line, we say this is the displacement. And second, there are many ways to represent this displacement, but the most favorite way is like we use the arrow tip line, or we use, just suppose if this is d, suppose it has 5 meter, and if this d is 5 meter, so this means there's a big difference between this one and this one. What is the difference? This is distance, like with the normal font, and this with the prominent font or the bold face, this d. So this is what the displacement. And also when you put the d on line under the d, above it, and the arrowhead below it. But as I said, the most favorite way to use a symbol is this one, d, and the arrow tip line over it. That is the displacement symbol. Then its unit. It also has the same unit as the unit of the distance, mean the meter, small m. And its family. His family is different as compared to the family of the distance. Distance was the scalar family, and this displacement belongs to a vector family, means vector quantity. Vector quantity. Okay, this was just introduction about the displacement. Now, what is its nature? How we can handle it and manage it mathematically and even the theoretically. It's a very important topic we use very frequently in the theoretical and the mathematical concepts. Okay, for example, let's see. First, we need to understand its definition. This is the origin. I consider one point. Okay, the origin for O. On the reference point, from here I took another point towards east. We know that here is the east. Always upper the paper is north and south, and here the west. Okay, so towards east, point for example A, towards east, that is for example 5 meter. Okay, so again this is here, this is the length between O and A, but this length is specific, in a particular direction. But if we compare the distance, there we didn't mention the direction. So if we mention the direction, means what I can write like this mathematically, the d is equal to 5 meter what towards east. I can write the same thing like displacement 5 meter, can write the two complete word towards east. Okay, so then how, by this concept, how we can make the definition describe what means of displacement is. So the short and smart definition, which always we can keep in mind, and even we can write and mention that what is the displacement, the distance with direction. Very simple. Distance having direction or with a particular direction, particular or distinct direction, is what? Is the displacement. Or same thing I can say, the length between 2 point places positions in a specific direction. Length between any two position points or places, positions, places, or points in a specific direction. In a specific direction is what? Is a displacement. It's called displacement. Okay, so this was the mathematically short and a brief description of the displacement. Now more it's mathematical work. Let me consider the example. For example, this is the origin. Okay, and for example, okay, better consider O. From here I consider another position B. If I put the arrowhead, now I made the immediate made it as a displacement because the direction is there from O to B. For example, this is 3 meter. Okay, and then let's see if I take another one. See, 2 meter more again towards east. So if I say what the displacement OB, that is 3 meter. What is displacement BC? 2 meter. What is displacement between OC? Must show the arrowhead above it. OC, so 3 plus 2, 5 meter, because they are the same direction. That's why we can add them mathematically. Otherwise, we have different methods to add the these such type of quantities, means vector quantities. Okay, so 5 meters. So this is the displacement from O to C. Now just see. Let me make the another way which we need to know. O, A till C. It was 3. Let me take the same number. 5. And now it is going back. The object is going back. For example, it reached at 2, covered reverse 2 meter distance. Okay, or if taking the direction, so displacement 2 meters is back. Now my question is, what is the displacement here? What is the displacement? Mean when the object is here, this is the object, moving object, reach at that place. This is the origin. This is the origin. So what is the displacement? So I'm sure that you know it. So what can be the displacement? Rather 3 plus 2, 5 plus 2, 7? No, this is the distance. So then what is this? Is can be the another options. What we have? We have only like 3 plus 2 plus 5 plus 2, 7. So 7 is the displacement. Yeah, you're right. It can't. The 7 can't be the displacement. So what is the displacement? Displacement, what is the current position? This is the current position. Origin. Where's the current position? This is the current position. Where object is current position. So the displacement is what? Another definition, another concept, important concept is that always we need to see the current position and the origin of the object. That gives us what the displacement. It means that here the displacement is what now? The displacement at position C, for example, this is position D, at D. Okay, right, capital D, at D. What is that? So here, how we read it? Very simple it is. I'm sure that you got it. That from this point till this point, this one. From current position, the box one, current position, to the origin, what is the distance between them? 3 meter towards the specific direction. Okay, 3 meter. So this 3 meter is what? This is the displacement at when the object is at T. Okay, it means when it is going to be reversed, just we have to see what the current position and the origin, what is the gap between them, what is the distance in the specific direction between them, that to the displacement. Okay, another concept, one point very important more. Let me take the same things and we'll extend to the next concept. So we have taken here O, then we go to the A. No, here I have taken OA, and then this I have considered before C. Then this we have considered D, and now suppose object reach back to E. It means that now if I ask you the question, this is the origin, okay, in the black circle, and now in green one, this is the current position. So if I ask, what is the displacement now? What came the displacement? It went to A, then it went to C, then it came back to D, and now it's read back towards the just parallel or the same place as the origin. So when it is at the same place, what will be the displacement? Can you answer? Think. This was 3, this was 2. So definitely this will be also 2 meter, this will be also 3 meter. So then what is the displacement? So here if you see the this concept what we have discussed before over here, that what is the displacement. Displacement is what? The distance between, distance or the displacement, distance between, this is the abbreviation of the between origin to the current position. Of course in specific direction. In specific direction. What I explained over here before. Okay, so if we see this, this is applied now over in this diagram, what happens? What is the now the displacement between origin, this origin, and the current position? It is zero. I'm sure that you know it is zero. Okay, because now actually, I mean, if maybe it is coming clicking your mind from here to there is some gap. No, this is not the gap. This is just the drawing work, just makes it. Otherwise what happens, the actually objects when it's went to A is went to B, C, and again it came back to A and then came back to the same position. So ultimately when it is over here, it means here there's a no gap between the origin and the current position. That's why displacement will be zero. Okay, the second last important point regarding to the displacement, which you must need to know all the time, what is that? Suppose this is the origin. Let me take the same example and extend it so that it be easy to understand. This was point we have taken C, this point we have taken D, this point taken we have E, where it becomes 0, and now it's going to the other side, for example till F. Now my question is very important to know about this, that when now current, this is the current position, where's that origin? This is the origin. So what is the displacement? Gap between the current position, mean the current position this, and the origin. What it is? For example, from A to F, I did give number before. Suppose this is 3 meter. It means, so distance can be 3 meter or something different. Can you think what it can be now? The displacement at F. Displacement F. This was displacement at E, sorry, when it was 0. Okay, so displacement at F. What can you make a guess what it can be, the displacement at F? So here if we see simple, I mean it is 3, but 3 what? 3 meter or something else? Think. I'm sure that you're thinking correctly that it must be negative 3 meter because you're working on the direction. Because if we say here, let me take some different colors over here. Like here, between this color, the blue one. Actually, if I draw here the axis, so this side positive x-axis from origin here towards a west negative. So if we see now the object is where towards the west, towards negative directions. That's why this will be minus 3 meter displacement. It means that that the displacement can exist in the negative. Important point. Displacement can exist in negative, having negative value. Okay, and displacement also can be 0, what we discussed above. Okay, so these are the two most important points. So, and there's another some details, I mean mathematically. No, one thing I want to discuss, then I will just close it, and then means other aspects mathematically I will discuss in the another video of the velocity. It's mathematical work especially. So what is the last concept? Last concept, just which we use also frequently. Concept is same, but the notations are the standard to how to handle it, just a little bit different. Just pay attention. For example, let me take 2 points. For example, this is origin O, this is position, for example A. Okay, better let takes like both alphabets. Suppose this is position A, this is B. Okay, and suppose towards B means we're talking about the displacement, must be directions. So if I say what is the displacement over here? Displacement So sometimes also we use displacement. You can see in some different textbooks the notes, and some people they use delta x, so it's also acceptable. Delta x displacement. So delta x is what it means, the change in the positions. So this position, for example, if I'm taking in the x formation, so I can say this is x1, this is x2. Or also another the notations we can use, we sometimes use in the different textbooks, xi initial position and xf final position. Okay, let me make it more proper readable. So I said this is xi, for example, initial position, and this is xf. Then what will the displacement in delta x? Okay, for example, that this is 0, and then when we reached over here, this is a 5 meter. So definitely no need to write the formula, just we write it will be 5 meter. But the question is why do I'm telling this? Okay, because there's a logic behind it. What's that logic? For example, sometimes they make a confusion here. Okay, the trick in such type of numericals. For example, this is the origin. From origin, this is the point from A, and this is the B. And here, for example, the reference point, the starting point is at 3 meter. It means 0 will be here somewhere else. Okay, but this just start from 3, and at the B position is, for example, at 8 meter. All right, or in the x notation I can say xi initial position is at 3 meter, and xf final position, f is subscript, is 8 meter. Then and must have the direction. What will be the displacement? So my friends, for the displacement, for use the equation delta x is equal to final position always xf minus initial position xi. Okay, so if I replace the values from here, what we have, x final is 8 minus 3 is equal to 5 meter, where towards east. So this will be the, or simply in the simplified form we can say delta x is equal to 5 meter towards east. So this is the another aspect of the displacement which usually we use in the calculation work. But still there's a calculation work regarding to the displacement. As I said in the beginning, that's important topic. So that, as I said before also, that please wait for the next video regarding to the topic physical quantity, the velocity. Ensure there, because this other calculation work is related to the equation of the velocity. That's why it's better that I will discuss at the same time where the calculation of the velocity and the calculation of the displacement as well. So till the next video, bye bye, take care, see you inshallah.